So in this video we will talk about the group trend. Group trend means if you remember the periodic table, so periodic table have 1, 2, these are the from top to bottom column are called the groups. So what are the properties of the groups from top to bottom? So we'll understand this in this video. So elements in a group have similar properties, almost similar properties if they have in a same group. For an example, hydrogen, lithium, sodium, potassium, rubidium, cesium, francium, they are all in same group, so they have kind of similar properties. Beryllium, magnesium, calcium, strontium, barium, radium, and then they also have similar properties. Likewise, halogen, fluorine, chlorine, bromine, iodine, astatine, and so they have all the groups which have the elements in the group, they are have similar properties. And trend also exist within the group, but there is some trend in the group. And group, what we have to study mainly: first A, second A, 6A, 7th A, and 8th A. So alkali metal, alkaline earth metal, oxygen group, halogen, and noble gases. And why hydrogen is non-metal. So alkali metal is first A, alkali metal is first A group, alkaline earth metal is second A group from top to bottom, and then oxygen group is here, 6th A, and then 7A is halogen, and then 8th A is noble gases, inert gases, 8th A. So these are the group mainly we will talk about. So let's start first from the alkali metals. In case of alkali metals, they are very soft, metallic solid. You can cut with the knife, and they are found only in the compounds in nature, not in their elemental form. So they do not exist individual, they are always found in the compound form. And typical metallic properties, they have luster and conductivity are seen in them. So they have very shiny luster, and then they can conduct the electricity. So this is the alkali metal, which is a group 1A, first from the left. And alkali metal properties, they have low density and melting point. So their density is very low, and they have melting points also very low. They also have low ionization energies. It means they can easily remove their electrons. So some properties of alkali metals: lithium, sodium, potassium, rubidium, cesium, and these are the electronic configuration. Neon, this is core electronic configuration: neon 2s1, helium 2s1, neon 3s1, argon 4s1. Melting point is starting from, you can see, lowest is 28 and maximum is 181. It's not much. Density is very low, 0.05. Water is density is 1, so it's not much dense. And atomic radius and then ionization energy is given here. So these are the alkali metal properties, that they have low density and melting point, and then they have low ionization energies, and they are shiny in nature, luster, and then they can conduct electricity. And okay, next is alkali metal chemistry. So usually all these metals, their reaction with water are famously exothermic. So whenever sodium or lithium or potassium, when you will add in the water, they will start burning. They will start immediately reacting with the water to form hydrogen gas, and hydrogen gas start get a flame, and lithium is also, this is for lithium, this is for sodium, this is for potassium. So all these metals chemistry are exothermic reaction whenever you will put in the water. Difference in alkali metal chemistry: lithium react with oxygen to make lithium oxide. Sodium react with oxygen to form peroxide. Rubidium, cesium and rubidium, potassium, rubidium, cesium also form superoxide. So metal, potassium, KO2. So this is the difference between their reactivity and metal chemistry when they react with oxygen. So lithium, when react with oxygen, it forms lithium oxide. Sodium, when it react with oxygen, it forms sodium peroxide. And potassium, rubidium and cesium, when they react with oxygen, they form superoxide. So these are the difference between the metal chemistry. And what is the difference in the flame test? So qualitative test for alkali metals include their characteristic color in the flame, and these causes by electronic transition. So you may have remember we have seen Bohr model while studying about the electronic configuration, and they are showing one line spectrum or like that. So whenever the lithium is burned, it form red color, sodium yellow and potassium blue. So these are the qualitative test. You can say that qualitative test of alkali metals include their characteristic color in flame. So this diagram shows that electrical energy used to excite the electron from 3s to 3p orbital, and then when they come back they release the energy. So this is because of the flame test. So yellow portion is emitted when the electron drop from 3p to the 3s orbital. So when they come back, they releases the energy in the form of color flame. Next is alkaline earth metal. So in case of alkaline earth metal, some properties of alkaline earth metal. Alkaline earth metal have higher density and melting points than alkali metal. So this is the difference. Alkali metal have low density and low melting point, but alkaline metal have higher densities and high melting point. Their ionization energies are low, but not as low as those of alkali metals. They can readily form +2 cation, losing the 2 valence electron. So you can see in the electronic configuration, they are all 2s2, 2p, 3s2, 4s2, 5s2 and 6s2. So they are easily tend to release or remove or donate or give these 2 electrons to attain the noble gas electronic configuration. So this is the difference between the alkali metal and alkaline earth metal. A little bit more about the alkaline earth metal. Beryllium does not react with water and magnesium react with only steam, but the other alkali earth metals can readily react with water. So this is the only exception, that beryllium do not react with water and magnesium react with only steam. So reactivity tend to increases as you go from down the group. So when you will go down the group, alkaline earth metal reactivity increases. So this is shows that when the calcium is dissolved in water, it forms calcium ion, and slowly it is reacting with water. Next is 6A group, which we will study in the next video. Which is mainly oxygen group.